Today we're going to talk about part 2 of 4.3, finding complex zeros. We already did this when we found our real zeros, so let's think about what we already know. The question is asking us to find the complex zeros for the following equation. I'm going to skip down to number 5 first because it's a little bit easier, then we'll go back to 4. If you look at number 5, it is a polynomial of degree 3, which means it has 3 zeros. We know that if it has a complex zeros travel in pairs. So it has one complex zero in pairs. So 2 of its zeros are complex. So the third zero must be real. So in order to find that, we do just like we did before, and we plug it into our y equals into our calculator. So go ahead and plug in x cubed minus 2x squared plus 16x minus 32 into your calculator. Then we know that one of the zeros is going to be either a factor of 32, positive or negative. You can look for that in your table, or you can look for it in your graph. Either way, we find out that one of our solutions is x equals 2. So to find the other two, or the complex zeros, we're going to again use synthetic division. Take the 2 and put it in the box. Put our coefficients in front, 1, negative 2, 16, negative 32. And draw our line. Do our synthetic division. Bring down the 1. 2 times 1 is 2. Add, we get 0. 2 times 0 is 0. Add, we get 16. 2 times 16 is 32. Add, we get a remainder of 0. So our polynomial is x squared plus 16. To find the other solutions, we're going to just take that and set it equal to 0. So in this case, since there's no x term, we're not going to use the quadratic formula. We can just solve it by using the square root property. Take the 16 to the other side, and we get x squared is negative 16. We know we need to take the square root of both sides to give us x equals, the square root of 16 is 4, and the square root of the negative gives me an I. So we have positive and negative 4i. So our three solutions are x equals 2 and x equals plus and minus 4i. So if I were to write those as factors like we did in the previous part, we would come up with the polynomial listed there. So let's try it again. Looking at example 4, what's the first step? You should be thinking, oh, I need to plug it into my calculator. So go ahead and in your calculator, plug in the 32 x to the third power minus the 32 x squared plus the 4x minus 4. Make sure you typed in an exact, because if you have it wrong, you're not going to find the right zero. Now, factors here we have factors of 4 are part of our zeros. So we have 1, 2, or 4. But notice how the a term is 32. So it could be 1 over 32, 2 over 32, etc. Let's hope it's a whole number. The easiest way I think to find this would be to graph it. And when you graph it, you'll see that it crosses the x-axis at 1. So one of our first solutions is x equals 1. So again, there are 3 zeros. We found one of them. We need to do synthetic division so that we can find the other 2. So we have 32 across the top, negative 32, positive 4, and negative 4. So when we divide with synthetic division, we bring down the 32. 1 times 32 is 32. We add and we get 0. 1 times 0 is 0. We add and we get 4. 1 times 4 is 4. We add, we get a remainder of 0. So again, our polynomial is 32 x squared plus 4 equals 0. I set it equal to 0 because that's what we need to solve. So again, since there's no x term, we're just going to use the square root property. So the first thing we need to do is take the 4 to the other side. So we'll have 32x squared equals negative 4. Then we need to divide by 32, and we get negative 4 over 32, which we know simplifies to negative 1 eighth. So this is where it gets a little bit tricky and brings in some of our old math. We're going to again take the square root of both sides. But how do we simplify this? Well, the square root of -1 we know is I, and we're going to take the square root of 8, but we need to simplify that so that it is 4 times 2, so it's 2 square roots of 2. So one more thing that we know, that we can't have a radical in the denominator, so we need to multiply the top and the bottom both by √2. So my final answer will be plus and minus I √2. We know that √2 times √2 is 2, so we have 2 times 2 is 4. So my three solutions are x is 1 and x is I √2 over 4.